All right, we're streaming. Welcome to Made Up of Wires. We are decompiling Castlevania Symphony of the Night, trying to get back to C code that will allow us to compile the original binary objects that were shipped in the PlayStation, PSP, possibly Xbox 360, Saturn versions of the game. Lately we've been going through weapons and decompiling a bunch of the functions related to weapons. If you're not familiar with the project, you can go to SOTN.z.dev, where we have progress for the objects that we're currently working on. The main game engine has been completely decompiled at this point and is portable, relocatable, which means that all the data that gets compiled into the main game can be modified, edited. We don't have to worry about memory offsets because all of the data is decompiled. Sorry, actually, the main game engine, there's one function left that hasn't been decompiled. The Richter program, however, has been completely decompiled. Weapons is what we're working on lately, and that has a ways to go. It looks like it is about 75% of the way complete. We'll see if we can get anywhere closer to that today. Then we have a bunch of the stages that have been decompiled. Many of them are either completely decompiled or getting pretty close. The debug room has a ways to go, and NO3 has a bunch of unique functions in it that haven't been decompiled yet, but I think everything that's duplicated there, with the exception of Entity Bone Scimitar, has been decompiled. You can find the source code on GitHub. There's a link on SOTN.z.dev to get to GitHub. Where you can find the source that contributors have made from decompiling, more information about the project and how to contribute, as well as the things that are currently in flight that should be merged soon. And there's also a Discord where we talk about things that have been discovered, ways to find answers to decompilation that maybe are hard to find. People are talking about modding, ROM hacking, things like that, changing sprites. Let me get things set up here. So one of the tools that is primarily used is decomp.me, which allows us to take assembly from the original game and have an editor which will do some decompilation, but then also compare the compiled objects that we'll get with the original assembly, allowing us to get to a decompiled function that will compile back to the same object that we originally had. So let's get started. I was looking at, we have a list of duplicate functions. And these are functions that if you can decompile one, then you likely get both or you get very close to the other. So they're valuable to decompile. The ones that are missing still, that are duplicated in weapon, I looked at these function or weapon 53 and 56. We can try those. They're relatively large, but that doesn't mean that they're complicated. I haven't looked at these 48 and 49. That one is actually kind of on the small side, so we could try that. Small doesn't mean easy. Large doesn't mean hard. And then these 54 and 56 weapon attacks. Those are about the same as the 53 and 56. So let's start up here, 48, 49. I think we'll take a look at them and then see how we're going to go about decompiling. So I'm going to take this this first one here. How to choose functions to decompile is more of an art than a science, but we'll take a look at this and see if there's anything that will trip us up along the way. All these are getting to be about the same size that are remaining, or on the larger side, so they're going to take a little longer possibly to decompile. Maybe not, depending on if they're very close to other functions. So this is what the assembly looks like for this function pointer 8017. So all the weapons have a set of 4 or 5 main logical functions, and then a collection of other functions that are specific to weapon types. The first several, except for entity weapon attack, aren't named yet, so we just use the offset into a structure that is used by the main game engine to name them. Let's look at this, the file that goes along with this one. It'd help if I had my terminal open. All right, so this was weapon 48. And yeah, this is the fourth function in the set of weapon functions. I'm not sure if anybody has gone through yet and categorized what, or understands what category these are yet. So we can look through it and see if we can tell what kind of what this function might be responsible for, and then maybe go back through some of the other weapons and do the same, and see if we can come up with a name as well. So I'm going to take that source code, I'm going to go back to decomp.me and start decompiling. There's a project set up for Symphony of the Night. We're using the PlayStation version, the Castlevania Symphony of the Night preset. I just regenerated my context for another function that I was working on. The context acts like a header file where your function definitions and other things like that are present, so when the decompiler comes in, it can see that a function is being called, for example, determine if things in argument registers are actually arguments, or maybe they're just being temporarily stored there. I'm going to go to the last weapon I decompiled and use that context because the one that I just generated was for the main program, and I don't think that it's going to have everything that I'd want in there. All right, so I'm going to create the scratch. And it's not happy with something. I pulled in too much. Get a new copy of that. So I'm pasting in the assembly, and the way that this assembly has been generated is by using a tool called Splat64, which was originally written for Nintendo 64 decompilation. That tool allows us to configure offsets into the object files that are on the PlayStation disk, and decide where those files should be broken up, and for each of those splits, what type of data is in that segment. So we know that this particular data is code, and so because it's code, then Splat64 will call out to a tool called M2C, which will decompile that, or sorry, it doesn't call it to M2C, sorry. It does the binary machine code language to assembly translation and dumps that in. And decomp.me then uses M2C to come up with this initial decompilation that will give us a starting point to decompile. And this one looks pretty nice. I probably should have set a timer on this one. Maybe we'll go backwards and see if we can set a new world record. On Thursday, we set a world record for the fastest decompilation of a weapon function in Castlevania Symphony of the Night, which is currently standing at 9 minutes and 23 seconds. I shouldn't have looked at the decomp, so this can't be an official time because I've seen too much already, but we'll see if we can beat the 9 minute and 23 second mark. And because this has a duplicate, we can do the other one and see if we can beat that time then. So in speedrunning fashion, we have our clock here, and let's see, 3, 2, 1, let's go. So I'm going to, first, we have a clean decompile, which is nice. I'm going to get rid of these, which are offsets into a structure that we know about. Normally I do this by hand to kind of also take the time to go through and just review the code, but if I'm going fast, I'm just going to go fast. Likewise, gplayer, that is also going to be struct access. And so I'm going to replace all those with access to a struct. The reason for those is we have memory offsets that are determined for these some of these fields, but the way that the program was written, they were originally accessed through structs, and so we need to do the same. Line 23 is not happy. I have a double dot. Get rid of that dot. 28. So I'm going through now and replacing those global names with access to each of those fields, which will get us back to recompiling. We're at 75%, which is pretty good. I'm going to go through and get rid of these go-tos. So when I see go-to block 20, this is going to be really just duplicating this code. Oops. And I'm going to paste the code for that particular go-to, and the compiler will generate the right thing. What does it look like? 126. So we got rid of everything going to block 20. Now let's look at block 21. There is no block 21. No, there is. So this is going to the default, which is likely outside of this switch. So we're going to get rid of all of that, take it outside the switch. Get rid of these. Let me go back. was right. Okay, we're a little further, but that doesn't mean that we don't have the right structure. So I'm going to go through and clean up a bunch of these variables and casts. Already being at 3 minutes, I don't know if this is going to be world record pace. That's okay. Bar v1 is an offset. Get rid of this step. Temporary. There's a bunch of math up there that we're going to have to work through. Down here, these are going to be out of order likely. And we'll deal with that in a little bit. GAPI, that is going to be struct access as well. I like to keep things compiling as I go. I don't think I'm going to be able to go through all the shifts within 6 minutes. But we can keep going and see how this works. So this destroy entity fell out. That is definitely wrong. I see. So we missed the while. Nope. Missed the end of this. Okay, closer. I do think I screwed up that pulling that block out though. So we're at 6 minutes, not close. I'm going to stop the timer and we'll go through this methodically. This one is not going to be a simple one, or as simple as I was hoping. So we'll go through and kind of line by line go through the decompilation process. So we're allocating a primitive. The convention there is to name that primitive prim. Sorry, that one will be prim index. The allocate primitives gives us an index back for the newly allocated primitives. There's effectively a list of primitives, and a contiguous array of primitives that is then used to store any primitive objects that are allocated. We can index into that array, which is here, this primitive buffer. And let's pull out some of these that have been used. In cases like this, where this register is being reused, this isn't This isn't going to be a primitive index. This is going to be the weapon's lifetime, which is at the same offset. ext is a union of several different structures that is used to differentiate what those structures are based on the type of entity that they are, and we know that this is a weapon, so we're going to use the weapon member of that union. We can get rid of this index variable. It's not necessary. And this other one probably is the same or similar. So we're decrementing this factory field and then checking whether or not that factory field is 0. Let's look at 93 and see if we have all that in place. So this has us branching. This was originally a go-to, and now we're branching I think when I replaced these go-tos earlier, I messed up some of the nesting logic. I'm going to go back and look at the decomp, the original decomp that was automated, and try to fix that. So this block here is only happening if temp v1 isn't -1. So we can't allow it to happen here. So we need to make sure that we return. All right. I think that will clear that up, but we'll see in a bit how that works. So I'm going to continue going through and look for some of these temporary variables that may not be necessary. So var_s2, we're getting the current primitive, so we'll use that, but we'll call it primitive, or prim. var_s1 is likely going to be our index in a for loop. So we'll pull this out and try to make it a for loop and see if that matches. So now we have to go through and get rid of all the things related to var_s1 that are no longer necessary, and or replace them with I. this prim2 we can just call prim, because at this point we don't need that other variable anymore, or the data that's in that other variable. We're multiplying the index by 256 before passing it to our sine and cosine functions. We'll come back to whether or not we need that or can do it inline. Here we're pulling these position variables or fields out into separate variables, but we don't need to, and the way that this likely looks is like this. Let's go look down in line 113 and see if that is changing anything. So our assembly currently looks like this. Our registers are mismatched. We have other work to do, so the registers might continue to be mismatched. I'm primarily focused now on whether or not we're changing the opcodes. So I'm going to do set these all on the same line. And they're not. So let's take this and we'll rename it to position X. We can still do these on the same line. And we'll name this one position Y. So this is the blue value. A lot of the primitives are split up into quads. So you have offsets of corners, and then what colors are at each of those corners. And I believe the PlayStation has hardware then to do a gradient across those four positions. In the 90s, it wasn't known that triangles were going to be the most efficient way to draw things, so a lot of early 3D hardware uses quads. And I believe Quake was originally written with quads in mind as opposed to triangles. So this B value, we'll just call that blue. And let's go back up and see what else we can get rid of. So we're still using that. This is going to be similar. We probably don't need to, well, we don't need to use a separate variable for that. Let's give both these the name angle for now. I don't always know whether or not the name that I give a variable is going to be reasonable or not. This primitive index is gone already. This looks like it could be angle as well. But everything is mutable, so we'll go through and fix those up as we discover what they're used for. If you're just tuning in, we are looking at a weapon function within Castlevania Symphony of the Night. There are, I believe, I looked at it this morning, 35 weapon functions left. Yes, 35 weapon functions left to be decompiled. There's 2 weapon objects. I'm not sure what the second weapon object contains. I've not looked into it at all. The first weapon object contains 58 weapons. So quite a few, and we have 35 functions within that. Each weapon contains between 8 and 10 functions. So say we had 500 functions within the weapons module. We're down to 35 remaining to be decompiled, and this is one of them. I started this decompile as go fast decompile, but then hit a snag and knew that it wasn't going to be a fast one. So now we're just going through it and treating it like anything else. This var 1, this is also going to be a for loop, so we can set that up, get rid of that variable. The team that built this was relatively judicious about their use of variables. I don't think that this matters. Maybe it does. This looks like we should pull it up. And we could probably inline those 2 things. Okay, we have a few more variables to go through. These are always going to be weapon lifetimes within the weapon object. So here we're going through and using that over and over. Again, we probably don't need a temporary variable for that. The compiler will pull it out for us. It knows that the value of this is not changing, so we don't have to worry about it trying to pull this in each time it needs it. But maybe it does want it in a separate variable. Let's take those out and get rid of this and see if those fall into line. They don't. It works out better like that. So we'll save that temp s3 and rename it and keep it around for now, and we'll see if we can get rid of it later. Of the ones we've done on the stream, this is actually one that is not falling into place as quickly as many of the others. And that's okay, because sometimes that's the way decompiling goes. When things like that happen, I'll usually go through and kind of clean up. I'd much rather have a nice clean function to go through and look at. These are kind of funny because they're out of order. They might be out of order as well in the decompiler may have put them out of order, and it looks like it did. So if you look at the assembly here, our original order was offset 11, offset 12, and then offset 10 for storing this byte. And what we're generating is 11, 12, 10, which is correct. Normally we think RGB, but for some reason this developer, however this was originally done, decided to do these in RBG order. We've registered differences, but our instructions are okay. Line 63 is not happy with the draw mode, so we're going to put this out of order. And that that brought all the instructions in line. For whatever reason, I guess it's because of the store happening down here. M2C, when it decompiles this, puts these out of order. But it's something that happens every time. So it's not difficult to fix. So going through and cleaning that up, not really paying attention to the progress. We're at 87%. I'm going to go through and get rid of some of these casts and type specifiers. When I'm decompiling, having extra noise around makes it hard for me to reason about what might be going on. One second. I'm going to look at this offset 70 and see what the equivalent is in weapon. That likely is more likely than this field. Again, it's naming things helps a lot when trying to understand what a function is doing. .7e is unknown 7e, great. So it doesn't matter whether it's the weapon or the factory. Might be good to go through and see if we can figure out what that does as well. Last week we had a discussion about one of the other fields in the entity structure, which was always used for animation frames, and went through and renamed it so that everything now, instead of having an unknown field, is using a nicely named animation field. All right, so now let's kind of go top down. And see if we can tell where some of these differences are. The variables that I've named, I like to separate from the ones that were automatic from the decompiler. We'll go through again and look at this. This I'm going to just put inline and get rid of that. It doesn't make a difference for progress, but that's okay. We still have these var zeros that are following this pattern. This is superfluous. This is effectively the same thing, so we'll just reuse var 0. The way that these variables are named is by looking at the register that's being used, in this case S0, and just either putting a temp or a var in front of it. I haven't looked into what the convention is for M2C, and this one we already got rid of. Okay. All right, so one of the first things that happens is storing a value into S1. Which is at offset 1c of ours. So we're saying take the address of the stack pointer plus 1c and put it into S1. So if we our stack is slightly larger than the stack of the original function, which means the compiler can't get rid of one of the variables where we're storing things because it may think that value is relevant later. Otherwise, GCC, even this vintage of GCC, is pretty good about getting rid of stack space necessary for variables that are superfluous. This unknown AC. Sorry, I don't have this up. I'm looking at so question from Project Omega: have we seen functions that are existing but never called? Yes. And the PlayStation 1 version has that because the compiler didn't automatically remove dead code. I should say dead functions that had no callers. I don't know if that's because symbols were exported in some way automatically, and so the compiler didn't know that it could get rid of those based on the way the overlays are constructed. In the PSP version, the MetroWorks compiler is able to get rid of functions that aren't called. And so we see a smaller code base for that PSP version. All right, so I'm going to go back and look for that 7C offset. or no, AC offset. Yeah, I thought so. AC is the animation. This is one that I just went through. And looked at. No, this is the current, maybe the current frame of the animation. So, okay, so in this case we're saying if we subtract 41 and we're treating this as a unsigned value, is it less than 7? Another way of saying that is, are we between frame 41 and 48? So let's try to figure that out. Sometimes I don't get that math correct. So the math ends up being the same, and the compiler will generate the same instructions. But again, for humans, we want something that that we can read easier. So let's go back and look at that again. So we're subtracting OX41. So what happens with an unsigned value is that it's going to overflow. And once it overflows, it'll be a high positive value. This is similar to the, if you've ever done the shop glitch, when you can sell 1 of something that you have 0 of, you're going to get the highest value of that, that thing in the shop. And then you can sell as many as you want. So we should be able to reason though. So if this is greater or equal to 41, we'll be fine, or less than 48. We should get the same assembly with that. But I see what I did wrong earlier. It's still ANDed with this unknown 46. But it's not compiling to the same thing. I'll leave it the way that it is for now since it was in place, but I'll come back later and try to determine why that wasn't compiling to the same thing. All right, so where are we? We have some stack space issues. We can look at each of these. Where are we using angle? And go down to line 38 in our decompiled instructions and see if where this is being used. Are we using 16-bit instructions, 32-bit instructions, 8-bit instructions? And I don't see any difference in those. So let's look at lifetime. Those I'm actually not too worried about. I'm worried about this 32-bit value because we're off by 2 bytes, and that would give us those 2 bytes. So there's a register difference. For kicks, I'm going to change it to a 16-bit. That did not change anything. And our other 16-bit is here. That doesn't change anything either. What if I make them both 16 bits? Does that fix our stack? It does not. So then we have a variable that can't be cleaned out by the compiler, and that's fine. We should be able to figure it out along the way. Let's look for instructions that are the wrong size. So in the decomp.me interface, we have the target assembly, we have the current assembly for the code that we're writing. We have some indicators here in this column as to what the difference is. So an R means there's a register difference. The variable is being stored in a separate register, or a different register than the original compiled code. In some cases, there is a stack difference, the S. An arrow means the code only exists in on one side or the other, in the original or in ours. So we're storing an extra word that the original did not store. I's are immediate values, which are hard-coded values, hard-coded numbers that are different. In this case, it's a offset, so where the branch is going. Line 14 is going to be this condition, and so if we meet the condition, what code do we jump to? And so I'm going to be looking for, so there's things like this on line 23 where we have code that doesn't exist elsewhere. And it looks like this that entities is being accessed, even though we just accessed it up here. And so why this isn't cached in a register, we could try this. The compiler hated that. Sometimes the way that the logic was originally written is different than you expect, or different than the decompiler expected. I'm going to try one more variation of that. No, it does not like that either. So let's see what's happening. So we have this branch. So the decompiler thought that it was using that variable again. but it wasn't. It was just mutating the existing field in this struct. And this is one of those cases where the compiled value, so we have an offset of 39. Nope. Negative value, let's see, negative. Okay, we got it. Okay, so let's go back and look at what the decompiler produced versus what the result ended up being. So the decompiler thought, I'm going to take this player value and I'm going to subtract 1f from it, so 16 plus 15, 31. I'm going to subtract 31 from this field and then assign it. What it ended up being was subtracting 5 from the field that's already been set. And if you look at what subtraction is actually happening, the compiler knows that I just set position y's high value to player position y's high value minus this, and I stored that value in v1, and I did some math on it and stored it there. But I still have that in a register. I'm going to reuse that register value, which is the same as player position I high. And I think the issue and the reason the compiler didn't take this and just reuse it is due to aliasing, which is the compiler doesn't know that this argument that was passed into the function does not overlap this global variable that we have. And so even though as developers we know this player is different from this particular entity that was passed in, the compiler can't know that. So it says, because this value is set, it's not a value on the stack, it's a value in memory somewhere that I don't control. I don't know that a side effect of this assignment wasn't to overwrite the value that were being pulled, so I can't rely on that value being the same anymore. So if I would do the math down here with this value, it says all bets are off on that value. I have to reload it because it could have changed during that assignment. This has nothing to do with threading or race conditions or anything like that. To the best of my knowledge, everything running on the PlayStation is single-threaded, so we don't have concurrency to worry about, but just this aliasing issue where the compiler can't figure out whether a side effect of this assignment would affect this original value. But it looks like that was figured out. So there's still register issues, but that's okay. Those will be worked out eventually. I'm still looking for cases where different size instructions are being used. There's usually a bar indicating that an instruction is wrong. So here's one of those cases. Here, the original instruction was a load immediate, so take this hex 20, so 32, and stick it in register V1. And our instruction is increment register S2. That's going to be done on line 46. So this I'm going to try pulling this up above. That doesn't help. The reason I tried pulling it up above, we have our load immediate instruction. It's happening out of order with what is happening here. And sometimes that ordering is due to how the compiler thinks it can load things at faster or slower. This increment, let's look at what S2 is. S2 is last set on 39. I'm not sure about that either. So we have a nice, fun, kind of challenging one today, which is, that's okay. 60, on line 60, this is a case where the immediate values are different, but there's no problem here. The decompiler just doesn't know that these are referring to the same thing. A lot of register differences. Same thing here. I still want to find some instructions that are the wrong size, because I think that we can get rid of the stack space issue, and once the stack space issue goes away, a lot of other things will fall into place. I'm going to go back to the automated decompile and think about this a little more as well. So here we're incrementing the step and then jumping down to this block. If we didn't do this, we would have destroyed the entity. So we might be missing a situation where yes, the entity was being destroyed. So I missed that when refactoring. But that doesn't get us closer, that gets us further. '69. Sometimes we can rewrite these as well, and I'll try that. This primitive index, if it's -1, that means that we couldn't allocate a primitive. And so what the idiom is in the game then is to destroy the entity so that we don't do any further processing on it because we've hit an error condition. And that does what we want. Our offset here, 3CO and 2C4 are quite a bit different. That is this jump, though, to destroying the entity. And our code is the same, it's just in the wrong place. And so why is it in the wrong place? Eventually we'll figure out why. This does not seem right. That helps. This is similar. We may be able to pull out this condition. Let's look at the decompile again. So if this initial condition doesn't hold, we're going to go all the way down, and then we're going to destroy the entity. So let's invert this and do that right away. So to invert things, we flip all of these. And then we're going to do this destroy. We'll reformat. And we got to get rid of all these blocks. That got us really close. Solved a bunch of register issues as well. I'll go back through that and why I thought it might work, and why it worked. Let's get back to something that's compiling. Okay. Howdy, Crudifar. Nice for you to join us. We're decompiling Symphony of the Night. This is a function within the weapon object. We'll be about 94% of the way through this particular function after this change. So the decompiler, the automated decompiler, came through and said, I think when this initial condition happens, we're going to do the bulk of the work, and if it's false, then we'll destroy the entity. And there's a bunch of branches and other things like that, but the thing that the original GCC compiler might not have been able to do is it will take code that it thinks looks very similar and try to reuse that code as much as possible. So here we're destroying the entity and returning. Down here we're destroying the entity and returning. Down here we're destroying the entity and returning. This mid-90s GCC, it can't cache a lot of these common instructions, but it'll try to get some of them. And it seems like by the time it gets down here to the bottom, it's decided I can't reuse that anymore, or I can reuse it, but I'm going to order it at the bottom and just have everybody jump to this one at the bottom. There's lots of different reasons why it might move that to one place or the other. But we can kind of coerce it into moving it to where we want it to be. And the way we're going to do that is by, instead of having the positive condition be our main game logic, we're going to flip that so that the positive condition is our negative side of the branch, and then continue through the rest of the function that way. And so we're at 91% here. We have we still have stack space is different from the original, a lot of register issues. So we're going to negate all of this. And then make this our destroy entity case. So now that jump, if we go back and find where that particular instruction is, that moved into place at approximately the same place. We still have slightly different values. We're off by, 8 bytes, which is 2 instructions between the two. So we still have, looks like 3 instructions. 4 instructions. 4 instructions? Okay. That the original doesn't have. No, it was 2, because this also is out of order. We'll figure out the ordering there too. But that got us a lot closer, and it looks like it cleaned up most of the register issues, which those can be hard to figure out. It had nothing to do with the variables that we had chosen or assigned, or the size of those variables in this case, just where that condition was. And is our stack correct now? Yeah, our stack size is correct as well, which is great. So we're close to 95%. That's good. We still have one of these. Let's see what S3 is being used for as opposed to S2. So these are being flipped, S2 and S3. We try to determine why that is. It may be because of this X offset. Let's try that. So here I'm going to do something similar. I'm not going to use a variable, but just make this a condition. And this is actually pretty common within these weapon functions, and I should have probably recognized this earlier. So here we're going to do our initial condition is going to be player offset plus 12, and we'll say if that equals 0. Otherwise, we're going to do player offset minus 12. And then we can get rid of this and have the compiler figure out where it wants to put it. Well, that didn't help. That's okay. Try reordering those and see if that makes a difference. And the last thing I'm going to try is let's set player out here and then either add or subtract based on. If neither of these work, I'm going to go and look at some of the code that's been decompiled already and see where I'm going wrong. Yeah, these didn't work either. I'll try one more thing. Yeah, okay, that didn't work either. So let's go look at some of the existing code and see if we have this. Elsewhere. So I'm going to look for places where facing left is a condition and weapons, and we have it a bunch. And I'm going to look I'm going to look a few lines before and after. So something like this looks very similar. Nothing quite the same. Let's look at this 58 and see what's happening there. No, that's not really similar. Let's look again. Looks like 52 follows that same pattern. It's possible that we don't have anything yet that is quite like that. Alright, so let's try to figure out what is happening then. So it looks to me like it's possible that that this position X high was never being accessed. Oh no, it is down here. So if we're facing left, then X high is being accessed. So going back to the original decompiled version. Okay. So that does look more accurate. The issue was more around, I guess, the register that's being chosen. In both these cases, S2 has been chosen when the original version had S3. And we see that up here as well. Do we still have RS0? Let's keep going, and we'll try to figure out what that might have been. So down on line 45. We can look these up as well. It's nice to be able to solve some of these as you're going, but it's important to optimize time as well. So if other people have solved these, I want to make sure that I'm leveraging their work. We don't need to re-decompile everything every time we start on one of these projects. So we're looking for the U0 V0s, but I'm not seeing that in weapons. Let's look in stages where we have enemies. Yeah, we have that pattern with stages. Let's look at warp. Warp is one of those places as well where there's actually a lot of stage code in warp, in the warp room, but in game there's obviously not a lot of stuff going on in warp. This looks like the same pattern that we're seeing. Maybe not exactly the same, but very similar. So back in the version we're decompiling, this shift of I by 18 and then shift back by 10 is equivalent to a shift to the left by 8. And a shift by the left to the left by 8 is the same as multiplying by 256, which is exactly what this other warp code is using. So we're going to base this section on that and see how close it gets. It doesn't have some of the other stuff around this primitive, the V0, V1. But we'll see if that how that shakes out, I guess. The same general idea of going through 16 different values in the primitive. I'm not sure exactly what. Let's look at what weapon this is. That's usually good to know. So this was weapon 48. This is the Thunderbrand, a weapon I'm not very familiar with. So let's clean these up. casts are typically unnecessary. So one of the things that is I'm going to order these so that they match. That screwed up those instructions. Let's move them back. Okay, so there is an add that's missing. In this other implementation over in Warp, the angle has changed along the way, and I'm not sure why the decompiler wouldn't have picked that up. So it's looking at the next value. And that lets that fall into place, and that gets us much closer, up to 97%. So let's go back to the decompile, the automated decompile. And that was my own fault for pulling that out, not realizing, that the value had changed. So I screwed that up along the way, and that happens as well. Oh, nice. Okay, so Thunderbrand does elemental lightning damage. Are there particular enemies that it is more effective on than other enemies? So the same thing is going to happen down here. This angle is going to be that same multiplied by 256. We'll see when this is done if this doesn't clear up a bunch of the register issues. And it did. And this is one of the things that can be frustrating when decompiling. So yes, the instructions were, there were a few things kind of out of order, and that was my own fault. And maybe if you look at that and say, okay, that should have been afterwards anyway because we needed that value earlier. But getting a correct instruction nearly all the way down at the end of this function is what caused everything above it to fall into place. And now we're at 99%. And there may be a few things up above that, some immediate values that are still not correct. And we should look at those. But my guess is that the remaining differences between this and the original are just the struct offsets that are missing. So anytime there's these entities with an offset, that's going to be struct access, and the value is not something that the decompiler in decomp.me is going to be able to figure out, so we can ignore those. Everything else looks like it is fine. So in this case, finding this this entity not in weapons but in warp, where oh, it is the warp room entity, so it is an entity that is being used in the warp room. It does something similar. So I'm guessing this has to do with some kind of rotational gradient. Project Omega, do you know if during any of the Thunderbrand animation, let's see if we can pull up the Thunderbrand animation. Oh, interesting. So it is effective against, it looks like, a lot of the aquatic creatures and bone creatures. I would think that some of the armored creatures would be, not in SOTN, but in general, I think of what is electricity going to be effective against. Dragon Blitz has a best and worst weapons ranking. That's going to be too long to go through. The Castlevania wiki does have some info about the Thunderbrand, obviously, but I don't see that it has... Oh, it does have animation. Okay, so the special attack is this one here. I don't see anything particularly rotational. I wonder if it has to do with the lightning that's coming up, if that's not sprites, if that's generated. Either that or it'd be the glow behind. It's only affecting X and Y. Yeah, thank you. All right. So yeah, if it's if that enemy is affected by elemental damage, it will do more. So let's go through and take our function, see if it builds into the game. Let's make sure that I have a clean environment. OBS, why aren't you showing me what's going on? Thank you. So everything's clean. This was function 0008. I'm going to paste this in. And so that compiles and it matches. So we did get a successful decompile. And that will, I'll send a PR out later to get that in. That ended up taking the full hour and a half, which I was not expecting, but that's okay. Let's go over some of the things that have been done in the Decompile project this week. So a bunch of weapon work. At the start of last week, we had about 56 weapon functions that hadn't been decompiled yet, and that was down to 37 by this weekend. We have another one gone. There's a couple more that got submitted since I did those numbers as well. So we should be in the low 30s for the remaining weapon functions. And at the pace that the decompilation is going, that means this first weapon object should be complete. I thought it was going to be another month based on our current pace, but it looks like 2 weeks. And weapons may be completely decompiled and portable. I'll say 3 weeks for all the data to be imported as well. But it looks like people are working on that as well. So just looking at some of the recent PRs, weapon, And then last week we had a bunch of other weapons down here as well. So a lot of that is getting really close to being done. Unfortunately, some of the weapon functions that haven't been decompiled are going to be the harder ones to do. So maybe it'll take a little longer. We'll see. In in the time it took me to do this one function today, I did. I got through most of 3 on Thursday's stream, and was able to clean up the rest and get those submitted. So sometimes they go fast, sometimes they don't, which is why it's hard to estimate the remaining work. A bunch of work has been done on NO3, which is one of the remaining stages that hasn't been completely decompiled that we've started on. There's still, I think, about a third of the stages between the first castle and reverse castle have been pulled out. So we don't have them all pulled out yet, but among those, NO3 is the one that has the most remaining code to decompile, but that's on its way as well. So I did some work around Merman. I screwed up my comment there. So there's 2 different Merman enemies, 2 variants of the Merman. NP3 and NO3 use the same implementation for both of those, so those have been decompiled. And there is some warg-related entities that are specific to NO3 that I may look at later today. We'll see. We'll see about those. So I think weapons is pretty much well on its way and should be decompiled, if not in the next 3 weeks, probably within the month. And that module will be finished. A lot of cleanup is being done to make it easier to pull in the PSP versions. PSP versions should be 99% the same code, but in some cases they don't match, and they don't match for a lot of the reasons that we saw today, where different registers are being used. So the logic seems fine, but something different about how that version was compiled or how the code is structured is causing a different different assembly to be produced on the PSP version that doesn't match where it does match on the PlayStation version. And I haven't looked too much at the Saturn version. I was looking at where are things that where's the work that's left. So there's some SDK work that needs to be done, especially in GTE, which is one of the graphics libraries. So there's a lot there. Weapon, so now we're down to 33. There's still work that needs to be done there. ST0 and NO3 work to be done there, and these are warp-specific implementations for the PSP, some work there. So we're getting close to the things that we've pulled out. I think, I'm not going to estimate the amount of stuff that's been pulled out, but there's been a little bit of just about everything that's been pulled out. The Bat Familiar is almost done. So we have familiars, we have weapons, we have stages, the main game engine, the SDK. We're getting really close on a lot of those things, and hopefully we'll see some of that finished up by the end of the month, if not sooner. That's all I have for today. I'll be back tomorrow, and we'll do another function. And if there's any other areas that people want to look at, please feel free to chat. Follow on Twitch. I post replays of all these on YouTube as well under Made Up of Wires. if you're interested in the project, go to SOTN.z.dev, where you can see a link to the GitHub page where all the public work is being done. There's discussion about progress in the Discord server as well. If you want to get involved, that's a great place to start to see what you can do. In general, I suggest checking the project out. If you're interested in contributing, check the GitHub project out. Try to get a local build going with your own copy of Symphony of the Night, and poke around there and see if there's any area of interest to you. Thanks, Project Omega. You have a good rest of the day too, and everybody else, you as well. Thanks for watching.